Hey guys, so we'll now quickly resume from wherever we had left. Just please ensure if you are able to see the board and you are able to hear me. Just give a heads up if you are able to see and hear properly. So say yes. Okay, cool. Great. So you are able to assimilate and understand what was discussed till now? You are able to understand everything that was discussed till now? Okay, great. So we'll move ahead. And first thing that we'll do is we'll practice one really important question, which is based on the concepts we have discussed till now. And that has been a very regular interview question also. So let me just finish erasing this. Okay, great. So tell me one thing, do you all know what a set is? Have you all heard what a set is? Yeah, so set is nothing but let's say a collection of numbers and a collection of distinct numbers basically. Okay, a collection of distinct numbers. So for example, let's say I have a set of 3 elements, which is 1, 2, 3. These are the 3 elements in my set. Now the question says that I want to print all subsets of this set. Okay, I want to print all subsets of this set. So do you all understand what a subset is? Yes, no, do you all understand what a subset is? Okay, cool. So can you tell me some subsets of this set? I'm just going to write down few of them. So first subset could be where everything is present. 1, 2, 3. Second subset could be where 1, 2 is present. Third subset could be 1, 3, then 1, then maybe just 2, 3, just 2, just 3, and then the last one could be an empty subset. Is that clear? Could you all follow what the subsets are of this given set? Okay, now let me ask you one really easy and generic question. So let's say I have a set containing n elements. Okay, a set containing n elements. How many subsets will be there? Can anyone tell me how many subsets will be there in terms of n? Okay, so I can see many of you are saying 2 raised to power n. Can anyone quickly type in here that why is it 2 raised to power n? What is the logic? So actually it is 2 raised to power n because I have got 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets. And 8 is nothing but, if you take a look over here, then 2 raised to power n, which was 3. Okay. Cool. Yeah. So Joybrat has given the right explanation. Because any element can either be a part of my set or it cannot be a part of my set. So for any element, I have just got 2 possibilities. For this, 2 possibilities. For this, 2 possibilities. For this, 2 possibilities. So if I multiply all of them, because corresponding to every take and untake, there will be a unique set. And you will understand it. Don't worry right now. So since there are 2 possibilities associated with each of them, and since there are n of them, the total number of subsets is going to be 2 raised to power n. Is that clear? How it is generalized to 2 raised to power n, 2 raised to power n subsets? Okay, now I want to solve this question. I want to write a program that, given a set, prints me all the subsets. Anyone who would like to tell me how do I proceed? So guys, this is very important. Just tell me your thoughts, what is coming to your head, how I can maybe start. You all understand the basic intuition. Basic intuition is any element can either be can either be selected or rejected. So I can see that, hey, these are some subsets that have been created by selecting this. Okay, and these are some subsets that have been created by rejecting this. Okay, did you get what I just said? I said a very simple thing, that there will be few sets that would be created by selecting ith element, and there will be some subsets that are created by rejecting this. And the same logic would apply for all the elements. We'll see that through pictorial view. Okay. So guys, now is the time everyone focus on the board, because this is going to be an interesting thing if you are doing it for the first time. So let us start our journey. So here is my input that contains 1, 2, and 3. 3 elements. Okay. Now, what I will do is, as I said, for any element, all the elements have a unique index in this set or in this array. For this, the index is 0. Okay. And for any index, either I can select it in my bag. Okay. Let's say I have a bag of numbers. Either I can select it in my bag of numbers, or I reject it in my bag of numbers. So let's say there is a function. Okay. Let's say there is a function that contains 2 things. First thing is I. I tells the index for which I have to make a decision whether or not to include it in my subset. Okay. So to start with, what should be the value of I? What should be the value of I to start with? Can somebody tell me that? It should be 0, because first I want to decide for 0th element whether it should be in my set or not. So let me start in this way. I start with the value of I as 0, and I start with a helper set or helper array which is initially empty. Okay, this is initially empty. Now I am at I equals to 0. What are the 2 choices that you have? Can somebody tell me the 2 choices that I have? Either include this in your set or do not include this. Okay, so if I do not include, I am marking this as no. If I include, I am marking this as yes. Okay, and now let me make the next function call. If I have decided not to include this element in my subset, in that case, this will continue to be empty. Is that not? In that case, this will continue to be empty because I have not decided to include it in my subset. And since I am done with this element, I proceed to the next element. So I will change my I from I to I plus 1, and this will remain as it is. So I move from f of 0 comma null to f of 1 comma null. This state has been achieved due to a no transition, due to a rejection of this thing. Is that clear? Yes, no? What I said, is that clear? Could you all understand? Okay, so I'll quickly repeat it again. So see, when you are, I have a function, right? I have a function that takes an index and decides whether the element at this index can be put in this or not. So as I said, I always have 2 choices for any element. Either I can include it or not include it. So let's say I choose not to include it, n is form. If I choose not to include 0th element in my subset, I proceed to next element, which is index 1, and this set continues to be empty as it was. Okay. On the other hand, if I decide yes, that hey, I am going to put this 0th element in my subset, then what happens? My subset contains 1, and I move on to the next index, which is index number 1. Is this much clear? Is this small thing clear to all? The logic that has been applied for the first call, which was for 0 index and empty subset, will apply across all. And let us see how it is going to apply across all. Here, which index I am at? Which index I am at? I am at index number 1. The element is 2. What are the choices that you have? Either you can include 2, which is yes, I am going to include, or you can not include 2, which is no. So if you do not include 2, what is going to happen? This will remain as it is. This will remain empty. And now, since you are done with this element, you move on to the next, which is index number 2. On the other hand, if you decide to include this first element, in your set, then what happens? Your set starts containing 2, and then you move on to next element, which is 2. Are these clear? Are these clear? Yes, no? How these 2 things have been produced out of this? Okay. Similarly, how many of you can fork this function call into further function calls? How many of you can do that? That's really, really easy, right? Because now let's take a look at this. See, these things that you are seeing here, which are function calls, these are also called as states. Okay, every state has a unique I and a unique subset. Okay, now here, when I am at index 1, again I have got two choices, either reject it or select it. Okay, so if I reject it, what happens? If I reject it, I move on to the next element, which is index number 2, and my set continues to just contain 1. But if I choose to select it, if I say a yes, then what happens? What will happen if I say a yes? Then this first index element, which is 2, will come into my set. So basically, I have transitioned to 2, comma, and this starts containing 1, comma, 2. Okay. Similarly, can you explore this further? Okay, let's do that. Now I am at index number 2. Okay, index number 2 is this element which is 3. So either I don't take it or I take it. So if I do not take this element which is 3, what will happen? What will happen? I just move on to the next index which is 3. 3 basically marks the end of array. Okay, index number 3 marks the end of array. Okay, and my set will continue to be empty. Because if you see this path, I rejected 0th element, I rejected first element, I rejected second element. So I started with empty, and if I follow this path, I am still empty. Is that clear? Is that clear how this path is empty intuitively? Because you selected those paths, you made those decisions. Okay. Now, if I say a yes, that means if I wish to include this second element in my subset, then what happens? This subset will contain this element which is 3, and then I move on to the end of array which is 3. Okay, clear? Same thing applies here. This is a no and this is a yes. So now I'm at second element. I can either choose not to take it. If I don't choose to take it, I move on to the third index, which is end of the array, and I just have a 2. And if I choose to take it, I move on to the third index, and I will have 2, 3. Okay. Cool. Audio and buzz audio. Is the audio better now, or any problem? How many of you are clear with the audio? Just say yes. Those of you who are not having any problem with the audio. So looks like those of you who are having problem, please use headphones. That will make life easy for you. Please manage it. That will be helpful for everyone. Okay, great. Now let's explore this. I am at index 2, which is 3. So either I cannot take it. If I do not take it, I move on to the end and I just have 1. Okay. And if I choose to take it, on the other hand, then what happens? I move on to the end, and along with 1, I have got 3. Okay. The last one, let's finish it off. No and yes. Second element. If I don't take it, I move on to the end of array, which is index 3, and I continue having just 1, 2. But had I taken it, what would have happened? Had I taken it, what would have happened? Can somebody tell me that? I would have moved to the end of the array, which is index 3, and I would have included this second element, which is 3, in my subset. So I would have got of 3, this would be 1, 2, and 3. Okay, how many of you completely understood this diagram that we have drawn? Okay. Now answer me, how many of you can actually write the recursive code for this? Can at least attempt writing a recursive code for this on your own? I just want to know that. Okay, see, now the game is still not over. Now here, when I am at I equals to 3, when the value of I is 3, what should I do? When the value of I is 3, that means, hey, the game is over. Now this entire array is over. When the array is over, then print the contents of your helper array or auxiliary array you took. So the first thing to be printed here would be this empty thing. Then just 3, then just 2, then 2 comma 3, then just 1, then 1 comma 3, then 1 comma 2, and then 1 comma 2 comma 3. Can you see how many subsets are there? Can you see how many subsets are there? These all things where we terminate are called as leaves. And you can see here that 8 leaves are there, and 8 is 2 raised to power 3. So I have been successfully able to print all the 2 raised to power n subsets. Okay, so my termination condition is being marked by the value of I. So if the value of I has become n, which is the size of array, that means I'm done with the array. So whatever it is which is there in my subset, I need to just print that out. Is the termination condition clear? Can you code the termination condition? Termination condition means the value of I becoming equal to 3. Yes, no, is that clear? Okay, great. Now, one point to be noted. See, this tree, if you take a look at this tree has got levels. Okay, this tree has got different levels. So at level 0, you are deciding about element at 0th index. At level 1, you are deciding about element at first index. At level 2, everywhere you are deciding about element at second index. So can you clearly see that first the size is 1, then 2, then 2 raised to power 2, then so on, it goes to n level, so it becomes 2 raised to power n. So what we had thought of 2 raised to power n subsets, that actually is getting presented here in this manner. Because for every element you have got 2 choices, and since you have got 2 choices, the previous choices that you had actually doubles for the next set of choices. Is that clear? Yes, no, could you all understand? How is it boiling down to these many subsets? Okay, cool. Looks like all of you have been able to understand it. Now, let us see how we can actually write a recursive code for this. So, recursive code is just about thinking of a proper function. So, I have to think of a proper function, and I have to think of some inputs that it is going to take. Some inputs. So you can already see that there are some inputs. Apart from inputs, you have to think, what are the recurrence relations going to look like? What I mean by that is, how a function is going to call itself over and over again. And the last and final thing, that what should be the termination condition. Okay, so let us just do that one by one. So I'll try to create a function over here, and then you will help me write that function. Okay, so let me name that function something like this, that returns nothing, that just prints. So I'll call this a void function, and let me call it print all subsets. So I'm naming this as print all subsets pass function. Can you tell me what are the inputs that it should take? What are the important inputs according to you that it should take? You know that I need a helper array, right? I need a helper array to be able to store the different subsets. So for that, what you can do is you can create an array, and let's say I name that array as star 10. Okay. And one more thing, I need to be able to know that how many elements are currently there in that helper array. Only then I will be able to inject the next element at its proper position. What I mean by that is, if the count of elements currently in my helper array is 2, that means next element will be inserted at the third position, which is second index. So for that, I will keep a count in C. That is my count. How many of you are clear with the 2 input parameters? Why I have chosen these 2 input? Okay, I'll repeat. So why do I need this helper array? You understand that? I need this helper array. Guys, by the way, those of you who are not so clear with, let's say, pointers and how to pass an array, don't worry about that. We will be conducting some more sessions where we'll cover those in detail. But this is the way you pass an array. You can pass an array by reference in this manner. Pass by reference means the same array is getting passed. Okay, you don't create a new copy. Okay, so there is someone, Sakshi is asking, why do I need a count? So I'll tell you why do I need a count. You saw in this recursion tree diagram that I have drawn, sorry I've erased it, but at every node, the size of array, which is my temp array, was different. Was it not? Was it not? Yes, no, at different levels, it was different. Now, whenever you are at an index I, you are either inserting it or not inserting it. Now, to be able to insert it at the next index of this temp array, you need to know how many elements are already there. Is that not? You need to know how many elements are already there. Let's say 3 elements are already there, then the next element will be positioned at index 3, which is 4th element. That is the reason you need this count, because there is no other way to determine the size of an array. You need to know it beforehand. Array is not like vector, whether you can do vector dot size. Is that clear? How many of you are now clear that why do I need a count alongside this temporary array? Okay, cool, great. Now we'll just start writing the code. So see, you will understand once you're clear with the concepts of recursion, writing the code is extremely easy because you don't have to write a lot. So we'll just quickly see that. So what did I tell you? There are 3 things about recursion: initialization, termination condition, and recurrence relation. So what should you write first? Should you first write recurrence relation or termination condition? What should you write? The logic where you are going to terminate. It's not the logic where you are going to terminate. Can you tell me the termination logic? Where am I going to terminate? I showed you in the diagram. We were terminating when our array was over. And when our array was over, the value of count was equal to the size of input array. Is it not? Is it not? When we were over, when we were at the leaves, the value of count was equal to the size of input array. So let's say my input array is a global array, which is something like this, and its size is, let's say, n. For simplicity sake, I have written it over here. So my termination condition would be that, hey, if, one thing to note over here is that apart from these 2 things, do you think there is one more thing that we need here? One more thing. Count can tell you the current size of this, and let's say the size of input array is globally known, which is n. One more thing that you want to know is the index of input array that you are investigating. Index of the array for which you will decide whether that element is to be put or not. Is that clear? How many of you understood that? Why do I need an I? Okay, I'll tell you again. So what was happening basically when I drew this diagram, see, I started with 0, this. So basically this 0 was saying, let's say my array was this. This 0 was saying the position in this array for which I have to decide, right? When you decide for this, then you move on to f of 1, something. So this is also important. This is a determinator of fact that which index of array would I be deciding for right now. Is that clear? Why do I need an I? Index, basically pointer to the input arrays element. Is that clear now? Yes, no? Feel free to say no if you did not get it. Anyone who could not understand this, why am I needing this? Okay, let's take that again. See, you started with f of 0, empty set. Okay, so 0 says that currently I am going to make decision for 0th element. So if you reject it, you move on to the next element, and then you are still empty. If you select it, you again move on to the next element, which is I equals to 1, and you have 1 in your subset. And then, so basically, as it goes on and on, now let's say you are here, you need to know that for which element, which index in the input array you have to make a decision of yes or no. Is that clear now? Count is different. Count is something that is different, and this I is different. Is that clear? Do you understand that? Count and I is different. Count is the size of this temporary array. Okay, the size of this temporary array. I had not taken count in the original diagram that I had drawn because the size itself, when I was drawing, was evident that hey, what the size is going to be. But here we need an I to be able to figure out that which index am I currently interested in. Is that clear now? Is that clear? How many of you got what is count and what is I? Okay, so you understand the importance of this. So I need a count. Count tells me what is the current size of my subarray, helper subarray. I tells me that which index in the input array am I going to decide for, whether it is to be selected or to be rejected. Now tell me, when you are at termination condition, when you are at the leaf of your tree, what was the value of I? What was the value of I when you are at the leaf of tree? The value of I was equal to n, where n is the size of array. Because I equals to 5 means that I am interested in fifth element of the array. And I equals to n means that I am done with the array. Okay? So if I equals to n, then what should I do? I should simply print this array. So I'm not going to write a lot of code here. Simply print this temp array. You can write a for loop to print this, and then you can put a new line because you want to print everything in a new line. Okay, and then you can write a return over here. Although this is a void function, but I said just writing a return means that you want to pop that particular function call from the stack. Sorry, but can we not do temp.size or temp. Muskan, see, temp is an array, this is not a vector. Had it been a vector, we could have done vector.size. But since I am assuming that most of you would be familiar with C, so I am doing it in C, and in C you don't have provision of array.size. You can't do that. Is that clear now? Why am I having to require a size for this thing? Okay, cool. Yeah. So we'll go ahead. Yeah, so when I have reached the termination condition, I'll print my temporary array, which is my subarray so far, and then I'll print a new line and then I'll return. So basically I'm terminated, I'm done. Okay. If let's say this condition was not true, if this condition was not true, what would that have meant? Can somebody tell me? If this condition was not true, that would have meant that I am at a particular index for which I am yet to decide, either to choose it or not to choose it. For example, let's say if I was at f of 1, let's say 1. So this says that I am at index 1 and I have already included 1 with me. Okay, so either I can choose this or not choose this. So if I don't choose this, I move on to next index with just 1, and if I choose this, still I move on to the next index, but with 1, 2. So let's first write code for yes, and then let's write code for no. Okay. So if we try to write that, shouldn't it be C instead of N? No. See, C is the size of temporary subset. C is the size of temporary subset. When you terminate, the size of temporary subset can be 0 also, because you have empty subarrays also as valid subsets of a given set, right? But I equals to N is the real thing that tells you that, hey, you are done investigating everything and now you should terminate. Is that clear now? Yes, no, did you understand why it should be I? Okay. Okay, now let's do first yes transition. For yes, what do I need to do? I need to put this element, which is my ith element, in my temporary array. So how do I do that? Which position will be empty? Cth position will be empty. So what I can do is temp of C is equals to array of I. So ith element gets inserted over here, and then since I have inserted it over here, now what I need to do, I need to call the same function, okay, for passing this temp and declaring that the size has grown by 1 because I have just included an element. So the size will be C plus 1, and then I move on to the next element in the input array, which was I plus 1. Okay. On the other hand, if it would have been a no transition, then then I just need to say that, hey, my count is still the same. I just need to say my count is still the same, and I would have moved to the next index in my original array. So it could be pass of temp, and my count will just be the previous count, and I would have moved on to the next element. That's it. This much is the logic. Counts in, but yeah, you're right. Okay, how many of you understood this code? Just say yes, those of you who understood this code. Is that clear? How I have written termination condition and recurrence relation and everything? Okay, anyone having any doubt in this at any line or anything? Can you tell me the last condition? So as I told you, whenever you are at ith index, either you can choose to include this in your array or reject it. So if I include this, I need to first put this at cth index in temp. So to put array of I at cth index in temp, this is the line I wrote. And now I need to tell the next function that, hey, I have c plus 1 elements with me. And since I am done with ith element, I want to move on to the next element. So this is I plus 1 and c plus 1. Okay. Now, if I were to reject it, then I just need to say to the next function call that, hey, my count is still the same. I have chosen to ignore this element. And now I will be deciding with the I plus 1 element. Is that clear? Is that clear? Okay, shouldn't we write the last condition before temp c equals to? Yeah, that's a good question. Actually, that is not going to matter. See, this array passing is passed by reference, right? This is passed by reference. What is actually happening here is, let's try to understand it in this manner. First of all, again, one more question. How many of you are now clear with the code? So few of you who are new to the recursion, it might take some time to digest things, but do you understand intuitively that how code is being written and how this is nothing but a carbon copy of the picture that I have drawn? Okay, so as and when you do more questions, you will be more comfortable with it. Okay, can we have Java code? So I can help you with that, you can ping me later on, but I really don't think that it'll be too tough to convert it from C or C++ to Java. It'll be really easy. Try that once on yourself. Okay, can you explain temp c equals to this again? So Nishi, I said that when you are at ith index, you can either choose to accept it or reject it. So in order to accept it, I need to put it at cth index in my temp. So I just put it and then I called the function. Yeah. So, okay, let us discuss that thing which most of you are now asking. So I'm going to just erase this, make things clear. Okay. So let's say I started off with f of 0, empty. Okay. I have a no, I have a yes. Okay. So 0th element, either I can choose or not choose. So if I don't choose, I move on to the next index and I am still empty. Okay. If I choose, then what happens is that I move on to again the next index, but I have a 1 with me. Okay. Let me draw this further. No, yes. If I don't choose to take it, I move on to the next index and I'm still empty. And if I choose to take it, I move on to the next index and I have a 2 with me. Okay. Now here, let's say I don't choose to take it, it's a no, and I move on to third index and I'm still empty. It's a termination condition. And if I choose to take it, then I have a 3 with, I move on to the third index and I have this second index element which is 3 with me. Now, just tell me one thing, this is my termination condition, right? This is my termination condition. So what is going to happen here? This array is passed by reference. So the same copy of array is being transported to different function calls. So these function calls chose to kept 0th slot as empty. This function call chose to kept 0th slot as 3. Now what will happen is that when this function call gets executed, see, this was ballparked, right? I told you, when this function call has been made, until unless this entire branch is over, this will not begin, okay? Now when this entire thing is over, right? This entire thing is over. Can you see that? How many of you can see that? Because whatever calls were to be made from here that have been made and that have all returned. Now when you come back to here, what it does is it sets 2 at 0th slot. So basically this overrides the value that was there at 0th slot. And this is the way it goes on and on and on. So different function calls keep on overriding the values which were populated by previous function calls. Is that clear? How many of you got it? How is it being overridden and how is the same array being used to print different things? Wouldn't the last statement overwrite I plus 1th element at position C? I plus 1th element at position C. So I didn't get your question, right? So is this right? Yeah, so if you take a look at it, that is exactly what's happening. Shazabeh, that is exactly what is happening. It's because the index here, let's say the index here was 0 because the count of this was 0. So you put 3 at index 0, right? Now when this has terminated, you came back to here. Here also the count was 0. Now you insert it at index 0, 2. So basically this is an overriding. And this is the same thing. If you draw this completely, what I would ask you to do is draw this completely and just keep moving in the way recursive code moves. So just ballpark this and execute this. For again this, ballpark this and execute this. And keep on changing the temporary array as and when the values are being populated and being overridden. You will be able to see how the same array is being manipulated and things are happening. Termination condition written after what wrong will be, I didn't get that. Which termination condition? Which termination condition you're talking about? Can you tell me that? Which termination condition? Written after what wrong will it be? I equals to n. Yeah. When you are at termination condition, then nothing is going to happen, right? Then you are done with it basically. You are not going to try to access third index of array or something or trying to insert it. So basically you are done with it and then you come back and then you see basically when you come here, you see that the size here was 0. So you attempt pushing new element at index 0. And the same thing keeps on happening. This is the way recursion works, right? When you are done with this, you come back to the previous thing and there whatever the size was, you take actions based on that. Is that clear? How many of you can literally see it, that how the temp array is being manipulated? It is being very intelligently manipulated to print different subarrays. Okay. So when you go back, just ensure that you simulate all these things. Then you will be able to gain more clarity. And if you have any doubt, you can write to me. I'll be more than happy to help. Okay, great. Now, do you want to solve a question on your own? Do you want to solve a question on your own? There is another yet easy question based on recursion. I'll tell you that. And then I want you all to think on that before we discuss. So let's say I have got a dictionary. Okay. Let's say I have got a dictionary and there are following properties of dictionary. First property is that max size of any word in this dictionary will be 3. So in this dictionary, words like A, words like AB, ABC, AAA can exist, but nothing like AAAC can exist. Is that clear? That is the first property. Second property is that the words will have letters from A, B, C only. So any letter of the word can either be A or be B or be C. So let's say AAC is a valid word because its size is also lesser than equals to 3 and letters are also from this. But anything like let's say AD is invalid because although its size is lesser than 3, but the letter D is not present in this set. Is that clear? How many of you understood the two properties of dictionary? Just say yes, if you got it. Okay, cool. Now you can assume that this dictionary contains all the valid words. This dictionary contains all the valid words that can be formed from ABC and having size lesser than equals to 3. Now can you tell me how are the words stored in dictionary? Are they stored in haphazard manner or is there some kind of order? If there is order, what kind of order is there? Yeah, lexicographical, or you can call they are stored in a sorted manner. Okay, so The question is that you have been given a number n. Okay, let's say the n is 15. So what you have to do is you have to print the first n words. First n words. Okay, that also means n lexicographically smallest words. I have to print n lexicographically smallest words. How many of you got the question? Let's say yes, all of you got the question. Do you understand what are the first and lexicographically smallest words? So lexicographic order basically means, let's say there are two words. First is AAB and let's say second one is AC. Can you tell me which one is lexicographically greater, AAB or AAC? Which of them would come first in the dictionary? Can somebody tell me that? AAB will come first. Why? Because lexicographic comparison happens in this way. You start from the first words. If they match, you move on. The moment they mismatch, whatever is smaller, that entire word is lexicographically smaller than this. In dictionary, you will find AAB before AC. So that is what lexicographic order is. Is that clear? How many of you are clear with what lexicographic order is? Okay. Now, how many of you can maybe print me some, let's say n equals to 5 or 10 lexicographically smallest words of this dictionary? Just try that out. Print it on your chat. I just want to take a look at that. What do you think will be the first 15 lexicographically smallest words according to you? So meanwhile, all of you try. I am also just trying noting them down on the board. So there will be, first thing first will be A, and A, B, then AAC, then AB, then ABA, ABB, ABC, AC, ACA, ACB, ACC, and so Mansi says AB. Mansi, not just after A, you will not immediately get B, right? Because after A, there is a sequence of words that start with A. And those all words are valid words according to the rules. And since anything that starts with A will always be lexicographically smaller than anything that starts with B. Is it not? Did you understand now? Okay, cool. So that is one thing that you have to keep in mind. By the way, this is the order from here to here and here to here. I think I printed all 15 of them. How many of you got it? The 15 words, how they are sorted lexicographically. Is that clear to all? Okay, anyone having any doubt? Okay, cool. Now the question says that given n, print me the first n words of this dictionary. Anyone who would like to take a shot at this and tell me how to proceed? If you know the approach, you can say yes, and then I would like to maybe unmute you and then hear from you how to go about this. So I am not expecting full-fledged solution from anyone. So guys, this is what happens in an interview. So out of all the interviews that I have taken for Amazon, we are instructed never to be interested in the actual final answer. The interest is invested in understanding your thought process. What is it that comes to your mind? So rather than knowing the solution, you should know how to think of the solution. What are the different directions that your thought can take? That is the most important thing. So again, anyone who would like to tell me in what direction you are thinking, you can just type. If you're comfortable, you can just type that, hey, this is what I'm thinking, would it work? And I'll be more than happy to put a comment on top of it. Yeah, anyone here who would like to do that? Okay, so let us all do this together, okay? So everyone focus on the board, we are going to solve this together. Akash says something. I will take first and will continue with it unless length equals to 3. Yeah, Akash, that's right. Maybe you need to formalize it a bit more, but that's right. So good. Okay. Let me ask you a simple question. Can I say that any word that starts with A, any word that starts with A, and by that I mean all those words that start with A, irrespective of their length, 1, 2, or 3, will always be lexicographically smaller than anything that starts with B. Can I say that? Can I say that? Same logic, does it apply here that this will be lexicographically smaller than anything that starts with C? Is that right? Okay. Now, one thing is sure that out of all the words that I am going to get from here, that is words starting from A, will all be smaller than everything that is here, and this will all be smaller than everything that will get germinated from here. Now let's focus our attention on this. Can I say that within all those words that are lying in this bag, all those words that start with AA and have something will be smaller than all those that start with AB and have something. Can I say that? Can I say that? All those words that start with AA will be smaller than all those words that start with AB. Can you apply the same logic here? The same logic here? All those words that start with BA will be strictly smaller than all those words that start with BB. Right? And the same logic can apply over here also. Right? Now let's drill down further. Can I say that all those words, now within this, all those words that start with AAA will be smaller than all those words. This is smaller because I don't have space here. Will be smaller than AAB and will be smaller than AAC. Can I say that? And can I say the same thing over here also? All those words that start with ABA will be smaller than ABB and will be smaller than ABC. So do you see? A, then AA, then AAA, then AAB, then AAC. Then you come back to AB. Then this, and this, and this, and so on. It goes on and on. How many of you are clear with what I did? This is just a pictorial representation of my mental model about how I'm going to approach. So guys, now how many of you can sense, I'm not asking for exact code again, how many of you can sense that recursion can actually help me here? Do you feel recursion can actually help me here? The answer is yes, because the way recursion tree grows is in a depth fashion, okay? It goes down deep and deep and deep and deep before going further, okay? And that is exactly what I want here. So now I'll just try to draw a recursion tree diagram to maybe help you out. Okay, so let's everyone look at the board. See, one critical thing to understand over here is that I want to print first n words. Okay, I want to print first n words. So first n words, let's say I want to print first 9 words. So I have to be careful about how many words we have printed till now. I have to be very careful about that because I don't want to print any extra word. So let's say I start with an empty word. Okay, you will understand why I am starting with an empty word. Because let's say if I have any word, I can create 3 more words out of it. First word would be previous word concatenated with A. The next would be concatenated with B, and the next would be concatenated with C. So this is empty, and since I don't want empty words in my dictionary, I can have a special condition in my code that if the current word is empty, don't print it. Don't print it. And then I move on to the next word, and my next word is going to be A. Okay? And here, the ones that start with B, and here the ones that start with C. Now you see, this entire forest that will come over here will be smaller than everything that will come here, will be smaller than everything that will come here. So it will go on like that only. One thing that I have to keep in mind over here is I have to keep a track of the count of words. Okay? So let's say initially the count is 0. I will not increase my count for empty word, but whenever the word is not empty, I will increment my count and I will print that word. So I will print A, I will increment my count, and then I will fork 3 more function calls. Concatenated with A, it becomes AA. concatenated with B is AB, and concatenated with C is AC. Now my recursion comes from here to here, so I am at AA. I print this AA out, and my count becomes 2. Now, when I am at AA, again 3 germinations are possible: AAA, AAB, and AAC. Okay. Here now I print this out, and my count becomes 3. Now what will happen? Now you come back to here. When you come back to here, you print this, count becomes 4. Then you print this, count becomes 5. And same thing goes on and on. When you have one more thing, when you are having word size equals to 3, you don't need to make further function calls. Are you getting that? Because the maximum size of word that I wanted was 3 and not more than that. So now from here you come back to here, and then you print this out. When you print this out, this is my 6th word, and this will give rise to 3 more, which are ABA, this is my 7th word, ABB, this is my 8th word, and ABC, this is my 9th word. Now here itself, I'll stop. One thing, when I make this call, I will have one more condition over here, that I will start the printing process. I will print if and only if the value of count is lesser than 9. If this is greater than 9, then I am not going to print it out. So I need a global variable count, which will be shared across all the recursive states. Is that clear? How many of you understood this tree diagram? Just say yes, if you got it. Can you implement this logic on your own? How many of you feel can implement this logic on your own? Okay, so let us all just try doing that. Okay. So let me write the code over maybe here. So let me call this function void print lexicographic. Okay. This takes in a string S. Okay. This takes in a string S. And now just help me with the code. Guys, I'm going to write recursive code. What should be the first thing that I should write? What should be the first thing that I should write? Why till 9? This is the question. Question says that I want to print first 9 lexicographic words. That's why till 9. Is that clear? Okay. So first thing that I should write should be the termination condition. What is the termination condition here? Who will tell me what is the termination condition? What is the termination condition? There are 2 termination conditions. Do you note it? First termination condition is when my word size has become 3. And second termination condition is when my count has become greater than this given value. Okay? So what I can do is, if my count is greater than n, or the length of this string, which is s dot length, is greater than 3, okay? In that case, I will simply return. That means I am not going to invoke further calls, okay? And in the other cases, what I can do is, in the other cases where I am comfortable, I increment my counter, okay? I increment my counter, and then I print the word, okay? But as I told you, shouldn't we include count in parameter of function? You can do that, but you have to pass that count by reference, okay? You have to pass that count as reference. Here what I chose to do, I chose this count as a global variable so that every function call can track that very easily. Did you get it now? What I did and why I did? I put this count as global, okay? Okay, now I can increase my count, and then what I can do is that if my S is not empty, if this is not an empty string, which are these cases, in that case, I will choose to print this S, okay? And then I'll make these function calls, which is print lexicographically for S plus A, print lexicographically for S plus B, print lexicographically for S plus C. Okay? So this simple enough code should be able to do this task for you. Could we print the string before termination condition like in the first example you gave? So Sakshi, if you do that, you will not be able to print them in lexicographic order. That is the difference between this question and the last question. Okay, here you have to print in the same manner in which your recursion thread is moving, because your recursion thread is the exact simulation of lexicographic nature of words. Okay, so you can't do this that when you are terminated then only you print, because then you have printed only some of these words, and that too not necessarily in lexicographic manner. That is the reason we need to write the code like that. Is that clear? How many of you understood this code? Just say yes, those of you who got it. How is this going to work? See, very simple things. Once you draw this diagram, things become very, very simple for you. Termination condition, you yourself decided and you quickly wrote it. That's great. Then you know that whenever you print, you have to increase the count. That you did. You know one additional condition that if this is empty, I don't want to print. So I added this condition. And then you made the 3 necessary calls. Okay. Parameter of print lexicographic. Parameter is just a string. Just a string. Just an input string. You keep on modifying that string, appending new characters and changing it, and then pass it over on and on and on. Repeat one. So Rahul, can you just type me what is it that you want me to repeat? N should also be passed as parameter, right? Yeah. This N, either pass it as a parameter or have it global. Up to you. That's your implementation choice. Yeah, Rahul, can you tell me that exact thing that you want me to repeat? What is it that you missed over here? What if array size, length array size is n? So there is no array over here. There is no array over here. There is a string, and the initial string that I passed was an empty string. And then I kept on modifying this string by appending it with new characters and then doing my operations. What if length of array is n, 26 characters? So there might be some edge cases. It might so happen that sometimes you get the value of n so big, which is greater than the number of words in the dictionary. So you need to handle that, and you can handle that easily. So for simplicity's sake here, you can assume that this n will be something which will be lesser than equal to the total number of words that your dictionary could have. Okay. Shouldn't C++ be after printf? Yeah, you can keep it after printf also, but not necessarily in this if block. You can keep this after printf also, but not in this if block, because I want to implement C even if I'm at this position, because I started with C equals to 0. Okay, they are small implementation level things. You can start with C equals to 1. That's totally up to you. The way you want to start and the way you want to change. That's totally up to you. Is it clear? Is the concept behind this question clear? How is recursion helping me print out these things in lexicographic manner? Okay, so there is one key takeaway that I would want you to memorize from here, and that is whenever you see any question where printing things in lexicographic manner or doing operations lexicographically is being talked about, just give a thought to it that can I use recursion to solve that? Can that help? Okay, great. So should we move on to the next question? Is everything clear till here? How many of you are clear with everything that has been taught till here? Just say yes. Those of you who were able to understand conceptually things over here. Okay, one thing that all of you should do is when you go back, please ensure that you write this code. If you get any problem, get back to us. We'll be more than happy to help. But please don't leave it away, because if you leave it away, it will be hard for you to catch it back later. Okay, let's do one last question for the day. And then, is there any iterative way to pass value A, B, or C? So, Akash, anything that you can do using recursion, you can also do using iteration if you use a stack. If you have your own stack, and if you push the parameters in your stack, you will be able to simulate the exact recursive behavior. Did you get what I tried to say? If you did not get, don't worry, because we'll train you that how you can actually use stack to solve the problems that can be solved using recursion also. Okay, arguments in this function. So currently the argument that I'm passing is just the string. Everything else, C, N, and whatever you can think of are kept global. Just for writing a simple code, simple enough and clean code for you. Cool. So now let's just move ahead. Okay, so before I move ahead, there is one very interesting thing that I want to talk about. You all recall the subsets problem that we just did? All subsets of a set. Do you all recall that? How did we print all the subsets of a set and we drew the recursion tree diagram of it? Say yes, those of you who have not yet forgotten it and have it in your head. Okay, great. So let me tell you one really interesting thing. So for that I have to draw the diagram, but it's worth the effort that I'm going to take. See, let's say the input is 1, 2, 3. And I want to print all the subsets of this set. What I did, I took a function where initially I have an I and I have an empty set. I is initially 0. I basically means the current index for which I am yet to decide whether to include it or not to include it. So there was a no transition. That no transition said that, hey, don't take it and move on. So this is this. And there was a yes transition that said that, hey, why not take it and then move on. And then again here, there was a no transition. I'll draw that this very quickly. So that to this, and then a yes transition that I have to again a no and a yes. So of 3 empty, and then again a yes, which is 3, 3. Let me draw for this also. Guys, you can draw on your notebooks. It will give you maybe better clarity than what I'm writing on board. 3, 2, and this would be for 3, 2, 3. So guys, I'm not going to do this for this branch. I don't have a lot of space, not time either. Okay, guys, let's think of it in this way. Can you see that any path, let's take another path, from root to leaf is a sequence of no and yes. Any path is a sequence of no and yes. Can you see that? How many of you can see that? Let's take this path. This path has been constructed from no, no, no. This path has been constructed from no, no, yes. This path has been constructed from this path, this. What is this? This is no, why, no. And this path is maybe no, yes, yes. Similarly, can you tell me what will be the rightmost path? Where I have everything, where I have 1, 2, 3, what would that path be? How many of you can see that path would be yes, yes, yes? How many of you can see that? Let's say yes, those of you who can see that path would be yes, yes, yes. Okay, great. So if you understand this, it is a great revelation. What is happening is, the positions which are no, 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 the positions which are no, no, no are not constituted in that corresponding set. So I get empty here. And the positions that are y are constituted in that subset which is getting printed. Similarly, for no, y, no, the position which is y, 2, that gets constituted, and that's why 2 is being printed. For this path, no, yes, yes, the positions that are yes are being constituted. How many of you can see that? Just say yes, those of you who can see that. So guys, if I treat no as 0, and if I treat yes as 1, can I say that a representation like 1, 0, 1 represents a set where I have 1 and 3? Can I say that? Yes, no? Okay, great. So, what is the binary, what is the decimal equivalent of no, 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 where I have 0, 0, 0? What is the decimal equivalent of this? This is a decimal number 0. And for this rightmost part, which is all 1, 1, 1, what is this? This is 2 raised to power n minus 1, where n is 3. Can you see that? So basically, if you see this clearly, see this was 0, 0, 0, which is binary representation of 0. This was 0, 0, 1, which is binary representation of 1. This was 0, 1, 0, which is binary representation of 2. This was 0, 1, 1, which is binary for 3. So if I just write the binary representation of numbers from 0 to 2 raised to power n minus 1, and then pick a representation and check which dots are on and extract those out, will I not be able to solve the same question without recursion? Can I do that? How many of you got it? Just say yes, those of you who got it. So this is another trick. Okay, so let me repeat it again. If my no is for 0 and y is for 1, can I say that any path which is from root to leaf is a sequence of 0 and 1s? Can I say that? Every path is a sequence of 0 and 1s. So the leftmost one was all 0, which was 0, 0, 0. And the rightmost one was 1, 1, 1. And how many subsets you had? That was 2 raised to power n. And from 0 to this, which is 2 raised to power n minus 1, how many numbers are there? There are 2 raised to power n numbers. So all that you have to do, you have to consider the integers from 0 to 2 raised to power n minus 1. And for each such integer, let's say you have 6, convert it in its decimal equivalent. I think this is 110. Okay? And for this, pick up the elements that are on. Okay? And that denotes a unique subset. Is that clear? Is that clear now? How I can do this iteratively also? So guys, this is a very, very important trick where using some knowledge of bits, you can actually do away with the recursive code and implement this thing on your own. Okay, great. So anyone have any doubt in this? Anything that you could not understand? Do one thing, whenever you go back, just draw this recursion tree diagram on your own. Would you be able to draw it on your own when you go back? How many of you are super confident you will be able to draw it on your own? Draw it on your own, mark every no as 0 and mark every yes as 1. Okay? And then plot every path as 0, 1, 0, 1. And then see, each path is nothing but binary representation of a number in between 0 to 2 raised to power n minus 1. Okay? And then this concept will become much clearer. Okay, so the last question of the day will you know. So guys, by now you should be able to understand that in which kind of questions can you think recursively. So which kind of questions exhibit the symptoms of recursion, from where we should practice the recursion problem. Guys, to connect with us, we'll be able to help you with some problems and resources also, so don't worry about that. Okay, tell me one thing. Can you find some symptoms in the problems that tells you that, hey, this problem needs recursion? Can you tell me under which conditions? Okay, so first condition is whenever you are moving from input space 1 to, let's say, input space 2. I'll tell you what input space 2 means. By making different decision yes and decision no. In that case, recursion comes in really, really handy. See, what was there in subset problem? I had an array from 1 to 3. Okay, so first, at this level, my input space was from here to here. And I either decided to choose it or reject it. Okay, so these are two different decisions. And then I move on to the input space, which is 2, 3. So whenever you see such kind of thing is happening, that your input space is, let's say, reducing, okay, to different input spaces with different set of decisions, you can actually exploit recursion in that case. Is that clear? How many of you got it? Whenever your problem that has an input space causes more problems with smaller input spaces, but with different decisions, you can use recursion over there. Okay, cool. So if you find it a bit tough to understand what I said, don't worry, it will all come with bits of practice. And today, if you are in the course of everything that I have discussed so far. Okay, so here is the question that I want to discuss now. So I have been given n pairs of parentheses. Okay, n pairs of parentheses. So parenthesis is nothing but a bracket. Okay, this is one pair of parentheses. Okay, so this is my left bracket and this is my right bracket. I can call that. Okay, so let's say your n is 3. What you have to do is you have to print all balanced parentheses. You have to print all the balanced parentheses that can be constructed from n pairs of parentheses. How many of you got that question? Just say yes, those of you understood the question. Okay, so those who did not understand, don't worry. But those who understood, can you just tell me the output of this? Just type in the output so that others can also see. See, you don't have to tell me how many balanced parentheses will be there. You have to print all those balanced parentheses that you can see. 3 pairs, okay? 3 pairs means 3 left brackets I have and 3 right brackets I have. So let me print them one by one. So one balanced parenthesis could be this, another balanced parenthesis could be this, another one can be something like this, then I have something like this, and then I have this. Is that clear? Is that clear? How many of you understood it? That for a given value of n, how are we printing the different balanced parentheses? Guys, what is a balanced parenthesis? Can somebody tell me what is a balanced parenthesis? So balanced parenthesis is something like, you can see this. This is not a balanced parenthesis. Why? Because number of right brackets, which is 3, is more than number of left brackets. So first important property is that number of left brackets should be exactly equal to the number of right brackets in the actual final string representation of parentheses. And second thing, at any moment of time, what I mean by that is, let's say you have traveled from index 0 to index 2 or from index 0 to index I, number of left brackets should be greater than or equal to the number of right brackets. So if you take anything, like if you consider this portion, this prefix, number of left brackets is 2 and number of right brackets is 1, and 2 is greater than 1. If you consider this, number of left brackets is 3 and right bracket is 1, 3 is greater than 1. If you consider this, both are same, which is 2 is equal to 2. So never it can happen that number of left brackets has become smaller than the number of right brackets. Is that clear? Is that clear? Yes, no? How many of you understood the properties of a balanced parenthesis? Okay, great. So coming back to the original question, given n denotes that I have n pairs of parentheses, n left brackets and n right brackets. I have to print out all the balanced parentheses that exist. How many of you are clear with the question? Just say yes, those of you who are clear with the question. What is the question asking me to do? Okay, now since this is the last question of the day, so I saw interrogation mark, so I'll repeat this quickly. I have got n pairs of parentheses. N pairs means n left brackets and n right brackets. And now I am having to print all the balanced parentheses that can be constructed from n left and n right brackets. Is that clear now? Okay, so yeah, since this is the last question, I would want somebody to give me some solution. Just tell me, not exact solution, again, tell me your thought process. How is it that you're thinking? What we can do here? I would suggest think step by step. Int left and right, okay. So firstly, give me some intuition, like how we can approach it intuitively. Insert, okay, so most of you are able to think recursively. That's really good. Yeah, now think how you can actually code it. Tell me the intuition behind the code that you have to write. Okay, so I think Shoaib is right. Yeah, you're thinking right. So that is one condition. Think more. Okay, let me ask questions. How many of you are thinking that I need to keep a track of the fact? Guys, please look on the board. I need to keep a track of the fact that how many left parentheses I have printed so far and how many right parentheses I have printed so far. How many of you think I'll have to keep a track of these two variables, left and right? Left says that, hey, till now I have printed, let's say X left brackets, and right says that, hey, till now I have printed Y right brackets. How many of you are thinking like this? Those of you who are thinking like that, good. That is the first thought that should come to your mind. Use a stack to keep track of open parentheses. Actually, you don't need a stack over here. Assuming that you are, putting the parentheses in the right manner, you don't actually need the stack. Think what you can do. Okay, let me ask a really naive question from you. That question is, guys, when, let's say I have printed some portion, of any valid balanced parenthesis. And that portion has, let's say, equal number of left and right parentheses. An example could be, let's say it has 2 left and 2 right parentheses. Can you tell me what should be the next parenthesis? The next parenthesis, can it be left one or right one? Yeah, open, close, what do you feel? It has to be a left one. How many of you are understanding this? Just say yes, those of you are understanding this. Take another example. If let's say I have something like this, where number of left is equal to number of right, I cannot choose to put the next parenthesis as closing one. The next has to be an opening one. Is this absolutely clear? Okay, great. So that is first thing that I want you to understand. So guys, let's think case by case. Recursion becomes easy when you jot down the different cases. Then you just have to convert those cases into lines of code. Okay. So case 1 is number of this bracket equals to number of this bracket. Okay. When both brackets are equal, let's say the situation is like this, I have only one transition. That is, the next bracket should be an opening one. Okay. Let's take another case. Okay. Can you tell me what can be another case? This case was when number of left parentheses is equal to number of right parentheses. What can be the other case? Case 2. If I am doing my work properly, if I am ensuring that I am putting number of left parentheses always greater than the right, yeah, the next case could be that number of opening brackets greater than number of closing brackets. In this case, what should I do? In this case, what should I do? How many of you think that in this case I have got two options? Since number of opening brackets is greater than this, I can make two calls. Either I can put an opening one here, which is this, and proceed, or I can put a closing one. How many of you feel like this? That there are two choices that I have here? Yes, no? Number of opening brackets greater than number of closing brackets. Okay, so it's good that you're able to think, but not exactly. Not exactly. Why not exactly? It all depends upon the number of this. Let's say I had 3 pairs. And number of opening brackets that I have till now is 3, and number of this is, let's say, equals to 2. A case could be like this, and this. Can you add another opening bracket after this? Can you add another opening bracket after it? The answer is no, because you have already exhausted all your opening brackets. You have used up all of them. But if that is not the case, if number of opening brackets that you have used so far is lesser than equal to n, then you definitely have two choices. How many of you are clear with what I said? Just say yes, those of you who are clear. When do I have one choice and when do I have two choices? Okay, awesome. So basically this case 2 boils down to two further cases. So I write them as 2.1. 2.1 cases, all my opening brackets are over. If they are over, let's say I have exhausted all my opening brackets, then the only choice that I have is to put the next one as closing one. And case 2.2 is that not all opening ones are over. If they are not over yet, let's say I have open, then I have two choices. Either I can close or I can open one more. That's it. So within this, there is only one case, and within this, there are two further cases. How many of you are absolutely clear with the two cases that I have noted down over here? Say yes, those of you who are clear with this. Okay. Can you convert it into lines of code? Once you are done with this, you just have to convert it into lines of code. Can you do that on your own? Okay, I can see that there are some yes. Okay, so what we'll do is, you understand one thing here, I need a count of left parenthesis that I have put till now, right parenthesis that I have put till now, and since I am using a string to put parenthesis at, so I need a string, and I also need index I. Okay, index I will tell me which is the next slot which is vacant, where I have to put the next parenthesis, be it left or be it right. Okay, can you tell me what would be the termination condition in this case? When should I terminate it? When should I terminate it? I should terminate it when I have used up all my left parenthesis and all my right parenthesis. So the moment n plus r becomes equals to 2n. Why 2n? Because n is pairs of parentheses. If I have n pairs, that means I have 2n parentheses. So the moment this becomes equals to this, that means that is a termination condition. No, left equals to right is not a termination condition, because this is not a termination condition. After I just have used two left and two right, I can use one more left and one more right. Now when I have got all in all left plus right equals to 6, which is 2 into 3, then I can say that this is a termination condition. Is that clear? How many of you got it? Another way to say that would be the moment this length of my string becomes equals to 2n, then also I can terminate it. So it's up to you how you are writing the termination conditions. Okay, so let us draw the recursion tree diagram, and then we'll jump on to the code. So let's say, my n was equal to 3. I had 3 pairs of parentheses. Is the same as I equals to n and r equals to n. So Anshul, I didn't get that. Consider typing that again. Okay, so let's say I start with this. So currently, I have an empty string. I have an empty string. Okay, this is my empty string. Everyone look at the board. This is utterly important. And I have 0 right parentheses and 0 left parentheses. I have got nothing at all. What was the first case? Out of the two cases that I jotted down, what was the first case? And which case applies here? Can somebody tell me that? What were the two cases that I wrote? First case was the number of left is equal to number of right. The only choice that I have is to put an open parenthesis. So basically now I have this. And how many left I have? 1, and number of right is still 0. Okay. Now here, number of left is greater than number of right. Number of left is greater than number of right. And I have not yet exhausted all my opening brackets. So how many choices do I have? How many choices do I have here? Number of left is greater than number of right. I have got 2 choices. Since I have not exhausted this, so see, first choice could be that I introduce one closing bracket. So basically this becomes like this. And then I have one opening, one close. And another choice could have been I introduce another opening again. So this is 2 commas. Okay. Now when I am here, again, which case will apply here? For this state, open, close, 1, 1 each, which case will apply? Left equals to right. So when left is equals to right, the only choice that I have here is to add, one more opening bracket. And since there is one more opening bracket, so this increases by 1, and this remains as it is. Here, what are the cases that I have? How many cases I have here? Number of left is greater than number of right. Since number of left is greater than number of right, I have not exhausted all my left brackets. I have got 3. So I have got two choices. Either I put one opening one, so I have 3, 0, and this. And if I choose to put a closing bracket, I can do that also. So this is 2, 1, open, open, close. And then according to the rules, it will go on and on and on. How many of you understood this diagram till here? Just say yes, those of you who understood this diagram till here. Can you continue this diagram and reach the bottom where this string becomes of size 2 into n and print that string? How many of you can do that on your own? So please, when you go back, ensure that you do this thing in order to print out all these things. Okay, now can you write the code on your own? Can you write the code of this on your own? How many of you feel you can write the code? So what I would say is, take this as a small homework. When you go back, just try writing the code, see how much you have understood. And if you are getting an error, just draw the diagram. You will be able to see where the error is. Okay? L equals to n and R equals to n. And this for termination condition. Yeah, there can be multiple termination conditions. I mean, that is up to you how you want to write it. Either L plus R equals to 2 into n, or both L and R equal to n, or string size equals to 2 into n. That's totally up to you. Okay guys, is this clear? How many of you are clear with the intuition behind this problem? How to solve this problem out? Okay, great. So I just had this much from my side today, and I hope some of you may now feel a bit more comfortable with recursion. How many of you feel like, how many of you now feel less afraid of recursion? Do you feel like your concepts of recursion have been made better? Are you able to see how recursion works and think through the problem, when to apply recursion and how to apply recursion? Okay, so we'll be continuing with these kinds of sessions which will be happening over weekends. Okay, and it will be great if you can join those. Ensure that you come for next weekend session also, where we'll extrapolate these things and we'll help you how these things help you solve dynamic programming problems. So tomorrow we will be organizing a contest that will be based on these concepts only. Okay, so just these concepts, if you are able to revise in the right manner and code these problems out, you should be able to solve many questions. Okay, so just go back and write the codes for this, and we'll mail you it won't be difficult. The contest won't be difficult. If you have heard to the lectures properly, you should be able to write the code properly. Okay, so there'll be a small contest. It will be from 9:30 to 11:30 times. Is that clear? Is the timing okay with you all? So that contest is, the purpose of that is not to judge anyone. The purpose is a self-evaluation contest. It is, we have named it self-evaluation. You are there to evaluate yourself, that how much you learned out of it. Okay? And then based on how you feel, you can get back to us, and then we can decide that, hey, how we can better help you. Maybe more sessions with this or something like that. So guys, that's it. I mean, I had just dismissed from my side. Can you please again explain the second condition in this question? See, second condition said that when number of left brackets is more than the number of right brackets. I don't have any right bracket now. I've got two choices here. Either my next bracket can be opening one again, provided that I have not exhausted all my left brackets. Okay? Or I can definitely put another closing bracket. That's it. So whenever number of left brackets is greater than the right bracket, you have got two choices. Either the next bracket can be opening or closing. Opening if and only if I have not exhausted all my opening brackets. And closing any day you can have. Is that clear? You get it now? Okay. So whenever you see a recursive question, try to frame the cases, and then you should be able to mostly do that. So that's it from my side. If you have any doubts or anything, I'll just write my email ID. So it is a bit big, but I think it might be helpful. So first thing first, you can always contact at support@programmingpathshala.com. So programming spelling you all guys know, and Pathshala is PATHSHALA. pathshala.com. And my email ID is Vivek same thing, @programmingpathshala.com. Okay, you can get back to me, and then sir, second way of what using bit vector. No, nothing like that. I can just do that using an array also. If you want, you can use bit vector also. It's up to you, an array of bits or whatever. Okay, so get back. If you have any doubt, any question in your mind, if anything else that you need from us, do write mail over here. You can put me in CC and I can get back to you. And then see you all in contest tomorrow, which happens from 9:30 to 11:30. And all the best for that. And do come for next sessions. That's it. Thanks everyone for joining, and see you guys again. It was really fantastic interacting with you. Bye everyone. Take care.